Hi everyone, I'm Felipe, and if you've ever wondered what your fellow Americans are thinking, then this tutorial is for you. In just 5 simple steps, we'll learn through using the general social survey data to answer the following research question.
Among whites, unsurprisingly, more religious people were more likely to be Republican. As we would know if we actually knew any religious or Republican people, we'd probably realize that ourselves. But then, if you look at blacks and Hispanics, it was negative. That is, the more religious people were more likely to be Democrats. Maybe the sample size is an issue. It looked pretty consistent, but it was based on a multi-level model, and I never trust multi-level models. Like, I want to see what the raw data. And so then I thought, let's do it with GSS. So this is my suggestion, to look at a GSS question, which I'm sure they have, about how important is religion to you, and correlate that with party identification, which I have on GSS, and look at it for whites, blacks, and Hispanics over time. This actually shows the pattern that we found in the NES. That's actually interesting, and it would be worth seeing if everybody knows that already. But maybe it doesn't, so this is why it's an actual ideal thing to do.
That was Andy Gelman introducing today's tutorial topic, elephants, donkeys, and religion in America. If you're not familiar with the GSS website, let the Google God show you. There we go. First, we want to decide what format we want the data in. And so if you go to the download tab up here, because I'll be doing this in R, I'm going to use Stata. Although really it's all the same after you import it. So now that we're here, you'll find different versions of the data. And we see that the most recent versions are listed here at the top. And this one will be the relevant one. It's pretty easy to just hit download. But once you've got this data set, you might not know what to do with it. So you want to look at the documentation. As boring as it sounds, it's actually pretty useful. Although you can definitely go through the entire GSS codebook right here. I really don't recommend that because it's about 3,600 pages long. I recommend either checking the index of the data set, certainly a much more manageable document, or else browse the GSS variables on the website itself. You can check the question and look at the distribution. So now that we've gone through downloading the data and looking at some of the documentation, we can move on to something a little more interesting. We're gonna go ahead and open up RStudio and see how we can load the data in. So you'll see I've already got a script. The nice thing about RStudio is that once you've set up a project for yourself, that'll be associated with all your R script files, your workspace, and your directory. Just in case, we're going to load the survey package, which is excellent for dealing with survey data, a forum package to load any kind of Stata files, and the companion to applied regression, just for some later analyses. I recommend typing question mark subset if you don't know what it does, and it'll pop up here. So once you've loaded the data and subsetted it according to what variables you want, here I've got an ID variable, year, sex of the respondent, age, education, region where the interview was conducted, their party affiliation, their religious beliefs, Hispanic, race, ethnic. I've created a variable called time just to keep track of the years that we're dealing with here. We've got the GSS from 1972 to 2010. However, for every year there are many missing responses, and we have to deal with these. So what I want you to take away from this script is that it's not always as straightforward as you might think to extract a variable from the GSS in a useful way. My brute force approach here basically takes 3 variables that are somewhat related to ethnicity and race, a kind of vague construct, and sets up a bunch of logical statements to determine which respondents may be classified as Hispanic based on the researcher's standards. Right here I've got my 2 key variables, namely religious importance to the respondent and political party ID. Make sure that the responses don't accidentally get changed when you go from a string response to a numerical response that will allow you to compute correlations and so on. I will have a note on weights later. This is a weighting variable, and it can be important, especially dealing with survey non-response and unequal probabilities of selection. But I will say that the GSS designs its surveys such that households all have equal probabilities of selection. So it is a self-weighing sample at the household level. But if you don't know what that means, don't worry about it. More on that later.
When your curtain falls, when your spotlight fades,
So in this part of the tutorial, I just want to go over some basic summary statistics and simple commands that'll get you pretty far with the GSS data. Assuming you've already got a convenient subset of the GSS panel data at your fingers, we're just going to run a summary command, and this is probably the most useful for any analysis before you start. And you'll see here that we've got all of our variables from the last part of the tutorial. This command really summarizes everything up nicely, so we can look at any variable. For example, there are roughly 24,000 males and 30,000 females sampled, or the mean age was 45.6, and so on. R also has a very convenient table command, so we can see that only 9% of Hispanics said that religion played no role in their life, whereas roughly 30% said they were strong believers. This cross-tabulation is a nice shortcut to seeing how the data might be broken down by different categories. So we can see that there actually doesn't seem to be that big of a difference in terms of religious preferences. And we see here that Hispanics were more democratic than whites. On the other hand, very few black people lean towards the right. This is a nice intermediate step before you analyze the data and might give you a better idea of how people responded. In any case, sometimes a picture gives you a better idea of the distributions. So I always find it nice to plot a histogram or a box plot of the data. And now that we've manipulated it such that our scales are numeric, R will let us plot a histogram. We can go ahead and run this code that I wrote earlier today. And as we can see, this is a pretty useful visualization. So for instance, on the question of whether or not you consider yourself a strong Christian or Muslim, depending on what they listed as their religion, people tend to say, not really. But a close second is yes. On the other hand, few say no or are atheists or what have you, and a comparable number of people have said that it matters somewhat. Similarly, we've got a histogram that shows the polarized nature of bipartisan politics in America, namely that most people are either strong Democrats or strong Republicans. In this graph, this is a bit confounded by the middle category since we've lumped all those who are apathetic or moderate or independent for the sake of simplicity of analysis. It's much harder to get anything from just looking at the numbers. You don't get a sense for the distribution until you really look at a histogram or a box plot. But if you're just going to work through something quickly, the summary command is going to be your best friend. And it's also helpful as it allows you to gauge whether or not the GSS has given you a numerical, categorical, or other variable. So as we get to the meat of the analysis, this is the part where we're going to look at the correlations between our key variables, namely whether or not someone holds strong religious beliefs and how they rate themselves in terms of political party affiliation. First, we're going to look at the overall correlation in order to get an idea of the aggregated relationship between these variables. And it's very straightforward to just use the correlation command on our data set. We might also consider the results aggregated over time, but broken down by ethnicity, as we've categorized Hispanics, whites, others, and blacks. Using the by command, we can easily break it down and look at the correlations by ethnicity. You might notice that these are quite different from the average. Finally, we can use the same command and with a little clever bit of code, view the results by year aggregated over the ethnicities, ranging back from 1974, when surveyors began to ask these questions, all the way through 2010. And we can see that it seems to be going up. But of course this doesn't answer the question that we asked at the beginning, which is looking at the trends in the correlation over time, broken down by ethnicity. So it's a combination of everything that we just did. For every ethnicity and every year, we have a correlation, except for when there's no data. However, this is not a very elegant response to our question. So what we're going to do is try to come up with a data structure that will allow us to plot these results nicely. What I've done is set up an indexing algorithm that very simply extracts the data from a messy list of correlations taken from each ethnicity for each year. So here we get rid of the years for which no data was collected. And now we have to also consider that when there's a correlation of negative 0.2, you don't really know until you've got a 95% confidence interval. Fortunately for us, there's a convenient command that is called core test, and it spits out a confidence interval for the correlation itself. So the correlation may or may not turn out to be significantly different from 0. In any case, we've set up a loop here to spit out the confidence interval for each year and each ethnicity considered. So this is what the loop spits out, and these all correspond to boundaries on the 95% confidence intervals. So this bit of code down here is pretty useful in actually organizing the data such that we now have a nice file that tells us year correlation in each year for each ethnicity and the range. So now we can come up with a plot that will show the trends in these data nicely. Now we're going to look at some more advanced plotting besides the histogram or your typical box plot. So this is a command that I rarely use, but it's convenient, and this will basically give you direct access to the variables by just writing their names. So we're just going to go ahead and plot this. So as we can see, this graph shows us the trend over time and the correlation between the strength of political affiliation and the importance of religion to the respondents. So for instance, in 1974, when the data first became available, it would seem that the correlation for Hispanics was negative, roughly negative 0.1, and it was also negative for blacks. However, an important point to make is that the shaded regions are very large for Hispanics and for others, so we cannot distinguish correlation from 0 in any years. This shows a great difference in the relationship between these two variables of interest for Hispanics, whites, and blacks. Within the subgroup of Hispanics, we just lack enough data to really establish conclusively whether this relationship was positive or negative, but most recently it certainly seems to be quite close to 0. And what you should take away from this is that with a little bit of effort and some simple plot commands, you can come up with some really nice graphics to visualize the data that you're studying. In this case, the research was mainly exploratory, so these trends are purely descriptive.